SwayamPrabha. Digital India. Educated India.
In the last lecture, we discussed about the different types of documentation of the historic structures and on the various aspects. And today we will talk about some of the case study to show, and we also talked about the importance of the investigation and diagnosis. So today we will talk about a case study where we will see that what is the role and importance of the diagnosis and investigation, and how that if it is not done properly, how it can lead to a very disastrous effect. If you remember that we have talked about problem identification, diagnosis and intervention option, and that how that leads to the conservation strategy. So, the case study what I am trying to discuss, we will discuss today, is a very famous case. This is the Leaning Tower of Pisa. Now, the Leaning Tower of Pisa is a historical structure. It is actually the bell tower of the Pisa Cathedral, is the campanile or freestanding bell tower, which is the attached to the or related to the cathedral in the Italian city of Pisa. The tower is situated behind the cathedral and is the third oldest structure in the city's cathedral square. It is known worldwide because of its unintended tale. So, we will talk about that, why this still happen, how this still happen, and what is the impact of that, and how it has been how and what are the remedial measures which has been taken, and how the decision was taken about it. It's a long story. Now, as we can see here that the tilt is quite a lot. The tower, which has been leaning almost since the building work first began in 1173, and the tower was closed to the public in 1990 because of the safety fears, and the 183-foot tower was nearly 15 feet off vertical, and its structure was found to have been weakened by centuries of strain. So, what I am following is this article which has been published, and you can also search into the Google, you will get it. So, there has been a very comprehensive study and discussion about the history of the till and what has been done and how the remedial measures have been taken. So, I am referring this particular article for my presentation today. Now, let us see the history of construction, how it happened. The construction is started first in 1173 in the August. The foundation of this tower was laid, and construction of that occurred, and basically it occurred in 3 stages over almost a period of 200 years. So, 1173 the work on the ground floor started, and white marble campanile began during a period of the military. That was the time when Italy was there are different states of Italy, and this was a prosperous period of that, and during that time the construction started. Now, immediately after it started construction by 1178, the tower began to sink after construction had progressed to the 2nd floor, not even to the present height, even up to 2nd floor. And the reason was that the foundation, such a long tower it was intended, but the foundation was only 3-meter foundation, and also the subsoil. The subsoil was very weak and unstable subsoil. So, we can see that it was a design that was flawed right from the beginning. The construction, when this was noticed that it started tilting, but also we must understand that any construction, any superstructure, when it is constructed, there will be some adjustment of the ground. They will try to sort of balance another thing. That always happens, but when it is continuous, and if there is an unequal settlement, and if it is continued for a long time, that is very dangerous. So, the construction because of this tilting, the construction was actually halted for almost a century. And there were other reasons also, because it was also a lot of battles were happening between the amongst the various states of this thing. And it also is a boon in disguise, because it also allowed the time for underlying soil to settle down. In 1272, the construction was again resumed, and there was a particular architect, Camposanto, and in an effort to compensate for the tilt, because they realized that the tilt is there, the engineers built the upper floors with one side taller than the other. So, there was a realization that in the superstructure some sort of adjustment will be required. But in 1284, the construction was halted again, and by 1390, so it was sometimes due to the construction, sometimes due to the battle which was going on. So, there were various reasons, and by 1390, the 7th floor was also completed, and by 1372, the bell chamber. What is the major purpose of this tower is the bell tower, is basically a bell tower. So, the bell chamber was finally added. But 1909, the overhang had reached the worrying value of 4.7 meter and was increasing at a rate of 1.5 meter per year. So, what is very worrying situation was that not only it has tilted a lot, but tilt was continuing. So, there were records. The records indicate that it started leaning since its construction. What the history says, that if you can summarize the points here, it was founded on a weak and highly compressible soil, and the movement went on for centuries, and adjustment was made during the construction in the masonry layers of construction. So, these are the some of the points we have to remember, that the soil condition was bad, there was a faulty design, and it started right from the beginning, and there was a gap in the construction time, and the movement was continuing for centuries. But also one must remember that the movement did not happen at an uniform rate. So, let us say the history of the tilt. During the first phase of the construction, to just above the 3rd cornice, the tower inclined slightly to the north. So, what we will see that even the tilt was not in one direction, the tilt was also changing in its direction. Then so it was an initial adjustment, and it almost stopped for a century, and in 1272, when it was again resumed, it tried to begin towards the south. So, we see that there was a tilting effect, and the tilting, first it was in north and then it was towards the south. So, the direction changed. The work again ceased when the construction reached the 7th cornice in about 1278, at which set the inclination about 0.6 degree towards the south. So, it had a rotational inclination, and during the next 90 years the inclination increased about 1. So, what we have to see, that the inclination changed the direction, another is the inclination was increasing over the years, almost along years. After the completion of the bell tower in 1370, the inclination increased significantly. In 1870, they started recording the first measurement with a plumb line to see what was the inclination, and there were record that from that time onwards that so, and then subsequently 2-3 records were there. So, we have a record that what was the inclination and which year. So, some sort of a rate and understanding, and it can be related with the construction history. Between the two measurements, the walkway surrounding the base of the tower, which is called Catino, there is a base, had been excavated to uncover the base of the monument, which has sunk into the soil. So, one side of that base actually really sunk into the soil, and the settlement was as high as 3 meter, quite a lot. And it was also found that when that Catino was digging or dug, it is seriously threatened the stability of the tower and caused an increase of inclination to approximately 0.5 degree. So, as we can see that some sort of intervention some adjustment was going on, there was a realization, it stopped and halted, but when something was being done. So, some intervention actually changed the, not only induced the rate, but it also the degree of the inclination or the direction of the inclination also changed. So, you can see that this is an interesting record what we can see, which shows the inclination of the foundation. So, as we can see that here, you can see that here it actually first the direction was in direction, and then we have a yearly record, and then that was changing. But here if you see that between these year 1278 to 1360, it almost sort of stabilized, the inclination was not doing, but again suddenly here we see a sharp increase of the inclination, then there was a stability here, but the inclination was changing. So, we see that we have a complete record of the direction of the inclination and in which degree the inclination. So, we see that the inclination was actually quite a lot, and in terms of the degree, and it is going more towards the southern side. And this is actually this abrupt increase of the inclination when a definite value of the height had been attained is a clear sign of an impending phenomena of instability in the structure of equilibrium, which is called leaning instability. And this is actually the phenomena which caused the problem. And this we can see that, if you can see here, that this is the catino, that this portion, that you see that how much sort of it has been within the ground. So, that inclination was quite clear. So, if you see that the monitoring actually happened when there was a realization that there was a inclination was still there and it was changing the degree, there was a recorded study for there and monitoring of the rotation which happened. So, now we can see that it increases more than the rotation of the foundation, implying that there is a steady deformation of the tower body, and the long term steady trend is marked by two major perturbations. That means, something was happened to the structure and which led to some sort of a perturbation. It was not happening at an uniform rate. Let us see what are these perturbations which happened. In 1935, it is caused by a cement grouting into the foundation body and the soil surrounding. So, people thought that if sort of a consolidated the soil around that and the foundation, probably it can give some strength to the thing. So, it was, and also it was done because there was a lot of inflow of the water. So, especially this was done to not only to strengthen, but also carried out to prevent the inflow of the water. In early 1970, it was related to the pumping of the water from the deep aquifers. Now, the soil is on a different layers and there is a underground water level. So, when there is a pumping happens to that taking out the water, what happens, the groundwater level changes, and that changes the structure of the soil structure, and including. So, what happened that when the pumping of the water was happening because of the development other around that area from the deep aquifers, it induced subsidence from all the Pisa plains. So, it was a greater area which was being affected by this change in the water level. It was not only localized, it was a much larger problem. So, what was decided when it was realized during the monitoring process, the closure of a number of wells so that the water cannot be extracted in the vicinity of the tower stopped the increase of the rate of the tilt. So, there was some sort of a positive step which has happened, that when they realized that the taking out the water was creating a change in the water level and that was creating the subsidence. So, there was an instruction or policy decision which really helped at least to stop the increase of the rate of the tilt. It appears that the rate of tilt is steadily increasing as not nearly double from 1938 to 1993. So, in the early 1990, the inclination was about 5.5 degree, quite a lot. Now, so different studies were taken by the government of Italy to understand that. Now, between 1902 to 1973, a lot of commissions were done by the government to study that what is the reason and what is happening. So, at least some sort of a recorded monitoring and other things happen. So, let us see what are this commission and what are the basic things they did. The first commission on the Tower of Pisa was installed by the Italian government. A number of investigations happened and the result presented in a broad and valuable report in 1912. Second commission also came. Its task was basically studying the possible means of stabilizing the tower. There was also an alternative commission which tried to talk about, or their task was basically to find less intrusive solution, so which can be stopped. And remember the word intrusive solution, that which should not really be very interfering with the structure. 1934 to 1935, so because of that 100-ton cement grout which I mentioned earlier and the chemical grout was done. So, it was basically a consolidation which happened to in the ground. The tower foundation and the soil surrounding the Catino was made watertight, because so that there is no water infiltration which is happening there. Water inflow into the Catino was effective. There was a time when the water had to be pumped out of the Catino because of the water infiltration. So, actually that really stopped. But what is happened, but it resulted in a sudden and marked increase of the inclination of the tower. So, when this was happened, that they changed the water infiltration within the basement or the Catino, that it actually changed the rate of this. So, about 100 years after the excavation of the Catino, again an intervention. So, that is why the line what we said there, the rate and other thing, the curve we saw, that it was not uniform, it was changing. So, suddenly an intervention carried out with, it was a possible, it was a wishful thinking, but which was, they thought that it will stabilize the tower, it actually threatened it. So, there was a war in between, the Second World War happened, and after the Second World War, the two wars were there. So, there was some sort of a disturbance and some sort of an not so much of attention was given, but so it became clear after the Second World War the tower was still moving. In 1949, there was another permanent commission to examine and evaluate a number of design schemes, that what can be done to that, and all of them, the design schemes which happened, they were very intrusive, and they did not, because the major concern that time was to strengthen the structure so that it does not fall or does not collapse. So, most of this design solution which came, we will have a look, that were intrusive and not respectful for the material integrity of the monument. 1957, the commission was dismantled, and 1964 a new commission was appointed, and international competition for the design and implementation of stabilizing work was the major task of this commission. But what is to be noted is that in this commission a geotechnical group was included for the first time. So, it was not only the structure, the realization was there that it has to be something to do with the soil and the geotechnical characteristics of the soil, which has to be also taken into consideration. So, this is one of the very positive step. Now, some of the solution proposed during that time. Let us see some of the solution which came because of this commission or because of the international commission and other thing. Let us see. Like say in this one, which was a proposal in 1963. Let us see what is being done here. So, what they are trying to do? They put another sort of a structural support there, and through that they are trying to sort of rest there. So, as a sort of an anchoring, so that it is sort of a thrust which is there and a support which should not be told, because but you can make out that how much it is a intrusive solution. This one, as you can make out that, I mean, this is sort of a propping up. It is trying to put some structures around this. It was sort of a propping up the structure so that it does not fall. In this case, you can, this because of the international competition, it happened that each and every layer of the tower, they are trying to sort of strengthen the structure in subsequently in all the layers through some sort of a cross reinforcement by the stitching, and this one, it was an piling under the, which they call cross piling under that, so that it was trying to go very deep into the soil and try to settle or strengthen the structure. This, you can see that there is the entire under the foundation of the soil, they are trying to sort of a cross piling, so that it strengthens the structure. And then it was another one which they are trying to take the piling only on one of the side, so that it does not. So, all of this, each one of this was a structural solution, came for very well known structural engineers and the groups, and where almost all of them were very intrusive solution. Fortunately, none of them were accepted by the commission there, though they are almost close to accepting some of the solution, but fortunately none of this was accepted and came to the final sort of awarding the tender. So, no contract was awarded. In 1983, a design group designing the stabilization did another intrusive solution as late as 1983. So, let us see what they have done here. So, they have also as you can see here is that they have put sort of this type of stabilization, and they are taking it down to the pile, and they are also putting underneath a foundation, and they are giving the piles here. So, this type of structural solution came, and it would of course be visible that this was an intrusive solution which they thought that will be working quite well. Now, finally, in 1988, a technical committee entrusted by the government was there to study the problem, and it sort of the task was there. It focuses the attention on the risk of the brittle failure of the heavily stressed machinery in addition to the risk of the foundation failure. So, that was the major intention of 1998 solution problem, and it was realized the failure of the machinery would be sudden and without any forewarning, and nothing can be done there. So, what happened, not only that it can collapse at any moment without any sort of forewarning, it was also became a concern for everybody, because it was a major tourist attraction place. A lot of visitors come there from all over the world. So, the safety of the visitor became a very a concern. Everybody became concerned about that, became a major issue. So, in 1989, the government prohibits the access of the visitors, but there was a lot of protest from the visitors, but it had to be done. The government then finally decided to install a father commission, a truly interdisciplinary one. That is to be saying that this also not only took the structural engineer, geotechnical engineer, it was chaired by a geotechnical engineer, and it had the art historian, the restorer, the structural engineers, and the geotechnical engineers. So, it was really in a true sense a multidisciplinary committee with all the experts, and the task was conceive and design and implement the necessary stabilization work. So, what they did is that already there were a lot of studies there was a record, there was a lot of thought which went behind that. So, a careful study of the behavior of the tower led to the conclusion that it was affected by a phenomena of instability of the equilibrium, as I have already mentioned, known as the leaning instability. Let us see what is this leaning instability and what was the realization happened due to the committee. It was like it also was realized that it depended on the stiffness and not on the strength of the foundation soil, because so far all the solution which came, it was trying to strengthen the foundation. Now, they realized it was depending on the stiffness, and this was something which can be realized if we try to understand the phenomena of an inverted pendulum. Let us say when a pendulum happens, what is that? There is a sort of vertical body. I mean, generally we see the pendulum there with, and there is a mass on the top of it. Okay. So, what happened? There are moments. One is that the moment of overturning and the moment of stability. Now, these actually creates a sort of a equilibrium. So, when it is in equilibrium, that means the moment of stability, the ratio and divided by the moment of the overturn, when the moment of stability is more. So, what happened, like a pendulum, it will go, but it will come back to its original position. But when these two are equal, when the moment of stability or the moment of stability and the moment of overturning, they are equal, then what happened? It will go and it will stay in that position. But what happens when the moment of overturning is more than the moment of stability, then what happens? It will collapse. So, these are the three scenarios which can happen, and but it was not the pendulum which was happening that way. So, it is almost a hinge effect, and it was trying to. So, if it is equal, then it will go and then it will come back. If it's this is more, it will come back, but if it's equal, then it will stay in that position. If the moment of overturning is more, then it will fall, and that depends also on that angle. That depends on that angle. So, this angle is very important, and that was realized that time, that beyond a certain angle this will become more. So, in the case of Pisa Tower, this is what is happening. The moment of stability is equal to the moment of overturning, and that is why it has stayed in that position. But the moment it will increase, then it will not be possible to take it back. So, that was realized, and this behavior actually led to what can be done about that. So, analysis led to the conclusion that a gradual increase in the inclination would have ended in a collapse. A decrease of the inclination, even a relatively minor one, result in a substantial increase in the safety against the leaning instability. So, this was a very important realization which happened because of the studying the behavior of the tower and equating with that the concept of the leaning instability. So, what was done? So, now what can be done? So, first is to reduce that angle, and how do you reduce the angle? So, some sort of a temporary measures were taken, a lot of finite element model analysis, structural modeling, the gravity analysis were done by the structural engineers, and it was saying that some sort of a thing which is temporary and fully reversible intervention to slightly improve in the safety against the overturning, this has to be what done. So, between May 1993 and February 1994, a total of 6.9 metric Newton of lead ingots was placed there on the tower. So, it was creating on one side of the tower, on the northern side. So, it was creating a load on that side of the structure, because it was leaning on the south side. And by the end of the July, it was found that there was a change in the inclination and it was improving. And then the average additional settlement of the tower relative to the surrounding ground at that time was 2.5 millimeter. So, that temporary solution by putting the lead ingots on one side of the tower was found that it was improving the situation. So, there is finite element model analysis was that, and there was satisfactory agreement between the prediction and the observation. So, there was a scientific way and how it was done there, and they found that it can lead to some sort of a solution. The progressive southward inclination of the tower, because of this putting the lead ingots, actually the tower has come to a standstill. That means that further inclination was stopped because of this temporary measure and putting an extra weight on the other side. So, deep insight of the behavior of the tower through an interpretation of the history, we must understand that it actually was a combination not only of the structural solution, it was combination of the interpretation of the history and all the records, the scrutiny of the measurements taken in the last century, the records were available, and the analysis of the phenomena of the leaning instability, that what we explained just now. These all three actually gave a realization of the behavior tower, and it was felt and realized a decrease of the inclination of the tower even by half a degree would have been sufficient to stop the progressive increase of inclination and to substantially improve the stability condition. And this was a very good step which was realized. And now this temporary solution which was taken had to be translated into a permanent solution, and how it can be done. It is quite simple. It is to induce a differential settlement of the tower to take it to the opposite direction. And how do you take this differential settlement? Acting on the foundation soil and not on the tower. It really did not need any intervention of the tower itself. The solution is perfectly respectful of the formal, historic and the material integrity of the monument. So, this was realized, and what are the three possible means? So, one was the construction of a ground pressing slab to the north of the tower. So, that on that tower, because we had to give an extra load, the consolidation of the clay north of the tower by electroosmosis, this is also an accepted methodology. The controlled removal of small volumes of the soil beneath the north south of the foundation, not strengthening, but taking out the soil, extracting the soil from the north side, so that it starts again inclining towards that. So, finally, this under excavation, that is taking the soil from the foundation of the north side, this was selected as a method. And for that, what was done is that this is what actually done, on the two sides of that, it was the stays were put up there, and so that there was some tie was there, and through the drilling process the soil was extracted. And as I said, a safeguard structure was put up with the horizontal stay on the two sides of the tower, and February and June 1999 preliminary under excavation happened. 12 inclined drill was there, and removing a total of 7 cubic meter of soil, 70% of which was the north of the tower and 29% was from beneath the foundation. The tower rotated northwards by 90 seconds of the arc. By mid September, the rotation had increased to 100, and so it by inducing a settlement, the inclination was sort of changing. So, this is some of the sketch. As you can see, the stays are there which sort of holding that in case something happened. There were the two stays on the two sides, and you can see the soil structure there, and the lead ingots were gradually removed, and this is how the drilling was happening to take or excavate the soil. So, the first it was done in a phased manner. The 3 lead ingots were first removed, and since then the tower exhibited negligible further movements, and then in 2001 and 2000 and 2001 the full under excavation was carried out, when a sufficient amount of soil which was calculated and which was done through the modeling and structural analysis, it was taken out outside the perimeter of the foundation. In the same period, all the lead ingots have been removed. In June 2001, the steel cable stays has been dismantled. It was there so that if something, in case of eventuality, if something happened, so the stays were taken down without having been ever operated. So, it was not there. So, that was that. After that, there was no sort of an inclination and happened, there is no further till, and as a result what has happened is that we have been able to save a tower which is a favorite of the tourists all over the world. You see, they come and try to see that. It is still leaning, but the thing is that by understanding the phenomena which was happening there, the problem has been solved. What is very interesting to see in this particular case, that there has been a scientific understanding, there has been a recording, there has been a multidisciplinary team, and fortunately all these intrusive things did not happen there. It was diagnosis, proper diagnosis of the problem and the solution which can take up. It is not very complicated, but that understanding was very much required, and of course, there is scientific investigation, and nowadays, which was probably not there 200 years back or 100 years back, a lot of modeling is possible, and to see that what is the likely impact which has been happened there. If you look at the history of the monitoring, recording and the others, it looked at it could have been a disaster, by either it could have collapsed, or just imagine that when all these structures or structural solution we have said that it would have happened, we wouldn't have seen the Leaning Tower of Pisa what we see today. But fortunately, by understanding the phenomena, the proper diagnosis, proper understanding, and by a multidisciplinary team and the recording, it has saved the Leaning Tower of Pisa. And this is the value of the, or importance and significance of the proper diagnosis of the problem, so that a proper intervention measure can be there. And that is why we know that all the news, the people all over the world are very happy. They said it looks like the Leaning Tower of Pisa is finally straightening out. The Leaning Tower of Pisa saved for 300 years, or Leaning Tower of Pisa is saved from the collapse. It was just, it was the rotation, understanding the phenomena and induce settlement, and so the rotation changes, and by taking out the soil from another thing, so that this was what was done not only at one go, but over stages in a very careful way, and by a conscious decision and study and investigation by a very multidisciplinary team to see. And that respectful understanding that what is really happening is a very important part of that. So, that is why we see that investigation, diagnosis, research, documentation and recording over the years for a historical structure, and how it can lead to saving the structure for posterity. Next lecture, we will talk about another very interesting case. Thank you.